So welcome everyone to another session of the NFI seminars. The speaker of today is Professor Patrick Sorgelos, and the title of this seminar is the International Artemia Aquaculture Consortium, New Initiative to Consolidate and Extend the Role of Artemia in Fish and Crustacean Aquaculture. As you know, the presentation will last 30 minutes. Then we will have 15 minutes for question and answer, and the session is being recorded. After the seminar, we will send the link with the recording and also access to the PowerPoint. You can also use the chat box during the presentation to write any question or comment you may have, and then during the question and answer slot, I will give you the floor to read your questions and comments. And without further ado, I will give the floor to Patrick.
Thank you, Amparo, and thank you, FAO, for giving me a chance to speak to you. And as you can see here in the overview, cover a number of issues that I consider quite important and timely in this sense that we all use Artemia, we all are familiar, but might not realize that there might be some problems in the future, and that there also are a number of opportunities that maybe we should better take care of. So I will go a bit through the biology, the history, and then focus on where proper Artemia management could better meet the SDG goals. So I think many of you know, but for those who are not familiar with Artemia, is a small shrimp that lives in brine waters at such high salinity where fish and other crustaceans cannot survive. And in order to meet these extreme conditions, has some peculiar characteristics. Quite unique is also the way the animal can reproduce. So the Artemia can reproduce by offspring that are producing live babies. So that means if you close this loop of the reproduction, that you can build up a big population. And then under other conditions, the mother Artemia will produce eggs that are fertilized, that are encysted, and then we are talking about cysts. And it is exactly these cysts, these dried embryos, that are a unique source of plankton, a unique source of live food. You incubate this magic powder, as I like to call it, in seawater, and within 15 to 20 hours, you can produce small plankton that is crucial food, starter food for quite a number of fish, marine, brackish, even freshwater, and for a lot of the crustaceans. Back in the 1960s, two companies in the United States, one in Utah, one in close to the city of San Francisco, started with the commercial exploitation of these, what they called at that time brine shrimp eggs. And that was mainly for the aquarium hobbyist market. This was the very, very beginning of hatchery aquaculture, particularly in Japan. So the world consumption of Artemia, as you can see here at the bottom, was less than 100 kilos. A very crucial event in the history of Artemia in aquaculture is the Kyoto Conference. Why? Because Dr. Ramu Pillai, at the opening already of that conference, was mentioning that we need to look for alternatives for Artemia. How can we develop food aquaculture in poor countries in Asia if we have to rely on hard currency to buy the cysts of Artemia to use as starter food? So as a very young graduate, I finished my PhD in '75. I was very ambitious at that meeting, and I was trying to convince the conference and Dr. Ramu Pillai that the situation with Artemia was maybe to some extent artificial. There are many sources. You can introduce Artemia, you can improve the techniques, you can use the Artemia biomass. So there was one man, I don't know if some of you in the audience have known Herminio Rabanal. He was the FAO representative in Manila. And he was the one who invited me back in '76 through FAO to do some training work at Southeast Asian Development Center in the Philippines. And this is where I really got the chance, following, let's say, a laboratory PhD study, to see how things can be applied in the reality. And the first challenge was to look into the possibility to introduce Artemia in an area here where you have a monsoon climate, no natural occurrence of Artemia, but during the dry season in most of these countries, you find small artisanal saltworks. And so the idea was to check if you can do a seasonal production. You inoculate the Artemia, you try to control the initial reproduction that you build a big population. And then at a certain moment, you see the animals starting to produce cysts, and you see the product that the salt farmer can harvest. So this was a very important first show for FAO that yes, countries like the Philippines, later on Thailand, Vietnam and others, there is a possibility to produce Artemia locally. And then there was a second important event, a lot of coincidence, because at the Kyoto conference representing Belgium, I was sitting next to the representative of Brazil, and he invited me to look at this area here in the Nordeste where there is a lot of salt farming. We were introducing, lucky enough, Graham will think about, lucky enough that I was introducing the right species of Artemia. I could have made the mistake of my life there, not realizing enough the importance of biodiversity. But within a few months' time, the first ton of Artemia cyst was harvested. And I could say this was really the trigger to convince the people from FAO, from the Kyoto conference, that yes, there is potential with Artemia. So in 1978, we set up the Artemia Reference Center. And right away, I was able to convince a number of colleagues and friends to join in the international study on Artemia, because we quickly realized, where in the past we were always talking about Artemia salina, that there are many different strains with many different characteristics. So it was these labs here in Belgium, Italy, Greece, Spain, UK, and United States and Chile, who started the so-called international study on Artemia. Quite a number, over 70 papers were published under that common heading. And this way we were able to understand better the biology of Artemia and develop the proper techniques for use in the hatcheries. We also had to come up with criteria to do the proper quality analysis, to be able to give the proper value in terms of nutritional quality, hatching quality, etc. So this was at the right time, because it was in the 1980s that we have seen the first expansion of the shrimp and the marine fish hatcheries. So techniques became available. People could use it in, for example, here, the hatchery in Ecuador. And that was the time that a lot of attention was given to the publication of manuals, knowledge transfer, organization of training courses in different countries, in different regions, and a number of symposia, a number of books were published in that time. Also, the larviculture newsletter, where the gray literature, very important in some of these applications. You cannot just rely on the scientific papers. A lot of the gray literature is important also for the farmers. So as of the early 1980s, the good news was that we started to see Artemia from Australia, from China, from Brazil, from quite a number of countries in the world. And one could, in fact, document the critical role of Artemia in the production of different commercial species of fish and crustaceans. And I think still today we can say that the key to a successful aquaculture is good aquaculture practices, good nutrition, good biosecurity. I will come back to that. So you can imagine that we have seen an evolution starting from small quantities of Artemia that were used in the commercial hatcheries. And today, so you see the gradual increase as we have seen the expansion of the hatcheries. Today, it's in the order of 3,000 to 4,000 metric tons of Artemia cysts that are used on an annual basis. We can value it at about $200 million US dollars. What are the commercial Artemia sources today? And I put in parentheses fisheries because I want to focus and pay your attention that 95+% of the Artemia today comes from natural sources. That means from fishing practices. So the Great Salt Lake in Utah is still the major source. I would say maybe 60% of what is consumed in the world comes from the Great Salt Lake. Then over time, as you will see in the next slides, a lot of different salt lakes in Central Asia, as you can see, and also China. What are the critical needs? Sustainable harvesting. With the coming slides, I will in fact explain that with one exception in the Great Salt Lake, most of the other sources, if not all, are not submitted to critical protocols, to critical harvesting restrictions. Then there is climate change impacts. As you will see, a number of salt lakes that are drying up, so Artemia sources that come and go. And of course, we need to make sure that those sites that disappear, that we should be able to preserve the Artemia gene pool. The Great Salt Lake is probably the most studied salt lake when it comes to Artemia ecology and population dynamics. It's a lake that is fluctuating with regard to its water levels. So if you see increased water levels or decreased water levels, I think you realize that this is linked with a drop in salinity, and a salinity that can go as low that there is no more Artemia because there is fish and crustaceans. And then at other moments, a long period of dry, very high salinities. So as a result, no surprise to see that the harvest quantities fluctuate a lot in the Great Salt Lake due to a number of parameters, no time to go into details. But as I mentioned earlier, about 20 years ago, a long study has been performed on the ecology and the population dynamics. And the US Fish and Wildlife has a very strict protocol in place to control the harvesting and to limit the harvesting in function of the presence of Artemia in the lake. No time to go into a lot of details in terms of technology, but where in the past all Artemia were harvested from the shore with all the possible impacts on quality. Today, the big companies manage to do the harvesting from the lake. What you see here is harvests of maybe 5 to 10 tons of cysts at a time. So as of the 1990s, and this was at the moment that there was a first critical shortage on the Great Salt Lake, a lot of efforts were given to look for alternative Artemia resources. In fact, following up what we have claimed before, there are many, many natural sources of Artemia, but okay, we have no good idea on what is the commercial potential. So it was FAO, some of you might remember Imre Chavas. He convinced me in the early 90s to go on an FAO mission to Iran. And then the Iranian government spent a couple of years, in fact, studying the population dynamics. We came to the recommendation to go for a very conservative harvest of 500 tons per year, but it didn't last long. The rivers that are feeding the Urmia Lake were cut off for agricultural purposes, maybe some climatic effects. Today, just maybe a few hundred kilos of Artemia cysts are coming out of that lake in Iran. Another interesting but a one-time event was the Karabogaz Gol in Turkmenistan. this lagoon is linked to the Caspian Sea, and in function of the levels of the Caspian Sea, this huge area, about 20,000 square kilometers, I'm wrong, is flooded, then dries up. During the period that the salinity is appropriate, there is a good Artemia population, but after a number of years, again, it dries up and it is a big salt flat. So the first half of the 1990s, several thousand tons of Artemia cysts were harvested from that lake in Turkmenistan. Today, the salinity is too high, even for Artemia, and there is very limited production. Another example is the Aral Sea, a former freshwater lake, also gradually, as you see the pictures here, dried up. So at a certain moment, the east, the big Aral, as they called it, the east part, the salinity was high, and still today there is maybe 100 tons of Artemia cysts that are being harvested, but this is a terminal lake. A few more years, no more Artemia in the east part. And today I was informed that on the west Aral, the salinity is now to a level where they are considering the commercial harvesting of Artemia. Another area which is certainly responsible for more than 1,000 metric tons of cysts a year is in this area of Siberia, Kazakhstan, Mongolia, where you find a lot of salt lakes, many of these very high productivity. Every year, this is the Bolsho Yarovoi, where some years they manage to harvest 600 tons of cysts, other years then it is a very low quantity. The low quantity might be due because there has been over-harvesting the previous year. So there are quota, but they are not very well implemented. They are not very well taken under control. China has also quite a number of inland salt lakes. The one here to the left is Aibi Lake in the Xinjiang province. Also some years good for 500 tons, but other years, because there has been a lot of precipitation, salinity is low, no Artemia, so very fluctuating harvests. Another area which is very important, the biggest salt production area, in fact, in the world is here in the Bohai Bay, where also large Artemia populations are found. There is a big exploitation of Artemia biomass, and cysts, it fluctuates also from year to year. So you see what I have mentioned earlier, there is really need to look into a more sustainable methodologies for Artemia harvesting, exploiting that natural fisheries resource. And I think this is something that needs to be considered at an intergovernmental level. And that's probably where FAO should and could play a role in the future. I'll briefly bring to your attention also the beneficial role of Artemia in the salt production process. This is something that could be further explored in terms of improving the quality of the salt, but particularly here to consider this as an extra opportunity for extractive aquaculture, cysts and biomass. I mentioned shortly after Kyoto the tests that were done in the Philippines to show the possibility to do Artemia production in seasonal salt operations. The longest experience is with the Mekong Delta in Vietnam, where at this moment it's already over 600 artisanal salt farmers who have been able to double, nearly triple their income by integrating the salt production with Artemia production. So today, during the dry season, it's production of salt, cysts, biomass, and I draw your attention to brine water, a very successful new development, also applied in a number of other countries, Thailand in particular, where 1 cubic meter of brine plus 4 cubic meters of fresh water, and you produce 5 cubic meters of excellent seawater that you can use inland. And then during the rainy season, where a lot of these areas are abundant during the rainy season, there is an opportunity to do local aquaculture. So I'm a strong believer that there is an opportunity to even pay more attention to that integration of salt plus Artemia production. The EU has just launched a 2.5 million euro project with Bangladesh, and I hope and I think this is where countries in particularly Asia, but also Africa and Latin America, where in many cases these solar salt industries or becoming marginal profitable industries could be integrated for aquaculture. And those of you who have not yet tasted Artemia biomass, anyone who comes with me to Vietnam or who is visiting the Artemia farms has eaten the Artemia omelette. The EU now wants also to see how in Bangladesh we might be able also to use the Artemia biomass in local, think about local crab cake, different local preparations. Over time, Artemia has been used as a model organism for quite some studies. No time to go into the details, but the nice thing is that you are dealing with a very handy experimental organism, particularly also that you can use it in a dried stage, the cysts, and with a very short generation time of 2 weeks, able to apply in a number of studies. And that will in fact provide even more opportunities now that the Artemia genome has been completed. In fact, the paper has just is in the review process. So different forms, different applications of Artemia are now widely used around the world in fish and shrimp hatcheries. We made a calculation on the hundreds of billions of shrimp post larvae that are produced, the tens of millions of fish fry that are being produced, and we come to an industry that is valued at several billion US dollars. And when you calculate from the numbers that are produced, Artemia is playing a role in the production of over 10 million tons of high value aquatic species. So we should not underestimate the critical role that Artemia plays in today's aquaculture. When you hear these quantities, you can imagine that a lot of developments have been made in intensifying and scaling up the production of Artemia. The two pictures I show you are shrimp hatcheries where they are consuming over 100 kilos of Artemia cysts per day. It is a bit surprising to see that although with all the manuals and the training courses that have been organized, that over the years, the attention to Artemia in terms of methodology, in terms of making a distinction between the Instar 1 and the Instar 2, the most nutritious source that should be offered to your fish or shrimp. Or if you don't pay attention and you just don't check the temperature or wait a few more hours, later you harvest the Artemia in a less nutritious stage and potentially contaminated with Vibrio. So a lot of the Vibrio problems in the hatcheries, be it fish, be it crustaceans, can now be traced back to inappropriate protocols in the production and the use of live food, particularly Artemia, but also rotifers and marine and microalgae. So what is the status now in terms of Artemia research institutes? So 4 of the ones that you remember that were involved in the ISA study are still active in Greece, in Spain, in Belgium, and in Chile, but several new ones, and I draw your attention because this is under FAO responsibility that the Asia Regional Artemia Reference Center was set up in China. FAO also was involved in the setting up of an Artemia Reference Center in Iran, although there are some problems there on who takes now the final responsibility. And I really hope that the Canton University, with a lot of experience in Artemia, can also become more involved in taking up responsibilities for training and extension. But then a number of other countries, India, Brazil, Mexico, Tunisia, South Africa, Kenya, Thailand, Russia, Sweden, Malaysia, or very active now with different research projects on Artemia. And I finish up with the Artemia production projects, of course, United States, but then we have, remember what I was referring to in Kazakhstan, in Turkmenistan, in Uzbekistan, in Ecuador, in Peru, in Mozambique, in Sri Lanka, in Myanmar, Honduras, Indonesia, Uganda, where Lake Katwe, there are a number of salt lakes, inland salt lakes, not only in Uganda, where we have good indications that where now there are some artisanal salt farms in near Lake Katwe, that there might also be a possibility to integrate with Artemia. I continue with Cambodia, with the Philippines, with Bangladesh, I was referring to earlier, Cuba, Argentina, Tanzania, and Madagascar, Egypt, Namibia. So I think from what we have discussed so far, that I'm convinced that there is a need to look into some new initiative, the International Artemia Aquaculture Consortium, to in fact consolidate and make sure that the Artemia availability in aquaculture can be guaranteed for the future in a sustainable manner, and that at the same time the opportunities that are offered through Artemia could also be better taken up. So in conclusion here, I will briefly list the different topics that should be addressed. Conservation of Artemia biodiversity. Well, the initiative of FAO and the work coordinated by Graham is a very good example on how this is followed up for Artemia. Then real need is to have a better control over this fisheries activity, namely the harvesting of the wild sources of Artemia, well, in particular in Central Asia, but this needs to be seen at the world level. More attention to that possibility to integrate Artemia and aquaculture production in artisanal salt farms. The project, for example, in Bangladesh, where more than 10,000 salt farmer families are involved, come at an appropriate time, because either this is an industry that will disappear because they can now import cheaper salt than the salt that they are producing in the Cox's Bazar area in the southeast of the country. But integration, first of all, an opportunity to produce local Artemia, and then at the same time integrate it for these artisanal salt farms into new aquaculture activities, with a very good example of what is done and practiced in Vietnam. Then what is the impact of climate change on the inland lakes, on the coastal saltworks? Better that we get an idea on this to look for future planning, future adjustments in the activities on these sites. With the availability of the Artemia genome, with the techniques that are now available in selective breeding, this is the time, I am very much convinced, to look into improved strains of Artemia through selective breeding, through application of a number of the techniques that are applied in aquaculture for other species. As I mentioned on the practical applications with Artemia, it's time, and we really need to address this issue of proper information. It's time to do an update of the Artemia manual, maybe use other ways and means rather than a printed version, maybe a PDF version with a lot of video clips to make it more attractive for the farmers themselves. Artemia webinars, training sessions could be organized. In fact, I covered this already earlier. And last but not least, what is now, what better work could we do to look into the potential use of that high value Artemia biomass in terms of protein, amino acid profile in local feeds? So where do we go from here? Well, I think these are questions that some of you in this audience might be better placed to answer. I think it should be FAO that should facilitate or pattern even the setting up of such a consortium. It could be at some of the Artemia reference centers that I'm mentioning there. It might be even time to see some of the centers in the south, in the countries closer to where the main activities are, to take up such responsibility. I know that we have been suggesting, but maybe could now see it in a better context, to link it with such an international Artemia Aquaculture Consortium, maybe its first activity in a kind of hybrid event, side event at the FAO NACA conference in Shanghai later in the year. Time to consider a new Artemia manual and a coordination of activities towards the SDGs within Artemia aquaculture. And again, I like to refer to Vietnam and the Mekong Delta model, early small-scale aquaculture, Artemia as a catalyzer for local developments in coastal aquaculture. Thank you.
Very good. Thank you so much, Patrick, for this very informative and interesting presentation. It's been very inspiring, at least to me, which is, I have to confess that it's not my direct area of work. And now I would like to learn more about Artemia. So now I will open the floor for questions and answers. We will have 15 minutes. Okay, I see Matthias raising his hand. Please go ahead, Matthias.
Yeah, thank you. Let me maybe start to get the ball rolling and thank Patrick for sharing this fascinating story going back to the 1960s and giving us some of this rich experience, and including showing us a picture of the young Patrick, which I haven't seen before. Very nice. As you rightly say, and as it came out very prominently in your presentation, from FAO side, we have done quite a bit to support the research and development of Artemia work globally. With Hassan being there, he has been a strong supporter of your work, and lately with Rodrigo, you have another good supporter. And I think we have done this because, as you have shown, the potential is really great. And Artemia for many countries, and Artemia somehow, at least in my mind, presents a really interesting example of where in a small way, I mean, it's not such a huge enterprise compared to, say, fisheries globally, but it shows how a diminishing importance of the fishery resource and the growing importance of the aquaculture of it raises many issues that we have to tackle. And looking at it from this angle and from this perspective is quite interesting, because the scale is not so huge. And therefore we can actually derive some important lessons from this, which is an interface between fisheries and aquaculture. And you mentioned the issues of conservation, you mentioned the issues of quota, and how this should be dealt with at an intergovernmental body. And I think we have brought this up at the aquaculture subcommittee, but it's equally relevant, of course, for a fisheries committee, and eventually to be raised at COFI itself. One observation, you mentioned this project, this EU project with Bangladesh, and how these salt works and salt farmers may be disappearing. Maybe something to consider is the GIAS, the globally important agricultural heritage systems. And I seem to recall that there's at least one GIAS in Spain, I believe, which is exactly from these salt works. So maybe that's an idea to pursue in the future. And then just very briefly, you mentioned intensification. That's of course important. but at the same time, decentralization of production to rural farms and the integration. Those seem to be very important also from an FAO perspective and focusing on small scale farmers. So just to say that from my side, I think you have very good suggestions for future activities. I think they are very well worth pursuing. And I'm very hopeful that with the support of our specialist, Rodrigo, and with the new team that we have created on implementation on the ground under Yuan Xinhua, but also under the team that deals with global processes and regional and global processes, there will be a good future for the Artemia work that you have so nicely presented. So thank you once again.
Thank you so much, Matthias. We have another two questions from the audience. We have first Melba, then Alessandro, and I think we have also one or a couple of questions on the chat. I will kindly ask you to be brief, please, because we have limited time. Please, Melba, go ahead.
Yeah, thank you. Thank you very much. Thank you very much, Patrick, for your excellent presentation. I have put my comments in the chat, and for a very quick question, I just wanted to ask whether there are facilities producing SPF Artemia these days, and where are they? Thanks.
Well, there is one company at this moment based in Thailand, but they have already units in India and a number of other places where they produce and sell SPF Artemia. But let me tell you, when you follow the handbook of FAO, each hatchery can produce SPF Artemia in their own facility. So this is where it is really important that people go back to the textbooks. And that's where I think it's important that maybe through FAO, we try to bring to the attention that each hatchery, when they follow the protocols, but they don't do anymore. And a lot of the problems are caused because of not using the proper techniques.
Mm-hmm. Yeah, because you know that for some of you who is familiar with AHPND, which is the most significant non-viral disease of shrimp, and this the brine shrimp can be colonized by this the virulent strain of Vibrio parahemolyticus that causes append. And as most of you know, the Vibrio parahemolyticus is naturally present in the coastal waters. Yeah. Thank you very much, Patrick. Nice to see you.
Thank you, Melba. I will take the questions from Alessandro and then also from Graham. Go ahead, Alessandro, please.
Thank you, Amparo. Good morning, Patrick. Good morning again. Thank you for this very nice presentation. Brought us back memories and how things happened, developed. It was so interesting to have this very quick overview. I have two things I want to mention. One is, as you know, I've been working a lot on technical publications, manuals here in FAO, and I think the idea of trying to produce an updated manual, it's certainly a need. And I think, trying to develop something which is a little bit more dynamic with videos, PDF, I think it's a very good and interesting recommendation. It's something that I'm interested in, and I will certainly discuss this with our feed expert, which is Rodrigo, and hopefully we can try to come out with something in the very near future. But that's one point. The other thing I wanted to mention is, my experience is mainly in hatcheries, so I have a little bit of a tricky question, which may sound stupid, but I think, you never know where industry and developments will lead us. But you know that a lot of live feed, artificial feed, which are being produced, are becoming smaller and smaller and smaller. So my question, which may sound simple, do you think that artificial feed will one day replace Artemia? If not, what do you foresee the requirements of Artemia in the future? Let's say within 10 years from now, will 3,000 metric tons be sufficient to see aquaculture growing, or we're going to have to kind of, aim higher? Thank you, Patrick.
Yeah, good question, Sandro. Let me tell you that it has been very important that over the past 20 years, we have been able to reduce the quantity of Artemia that is needed to produce 1 million PLs. I just give you the example for Vanamee, where initially it was 25 kilos of Artemia cysts to produce 1 million PLs. Today, it's 3 to 4 kilos. And many hatcheries and many companies have now realized that they are going below the critical minimum. Companies like CP and others have increased again because they have seen that the quality of the PLs, and it's only at the harvest that one sees the effect. So reducing the use of live food, definitely yes. Replacing, well, this is 30 years that I hear from companies, this is the end of the Artemia, this is the end of the Artemia. What is so vital about live food is the fact that it is not only a good nutrition in a small size, but containing the digestive enzymes that help the animals to go through that critical phase in the larval development. So with the further expansion of hatcheries, we will need more Artemia, but per unit, I think for some species, there is still room to decrease. For others, we are really at the bottom when it comes to, for example, the penade shrimp.
Thank you, Alessandro and Patrick. Now I will give the floor to Graham, and then we will officially close the session, but we will keep the meeting room open for further discussions. Please, Graham.
Thank you, Amparo. And thank you, Patrick. It's very nice to see the history of this, and particularly having coincided with you during a lot of that period. I thought the exercise we did very recently on the development of or classification of the farm types of Artemia was very interesting, and then I would like to reiterate something I mentioned on our last call, that I would like to find some way to publish that element of this very big Artemia story. But I want to ask another question now, which is, you mentioned and you noted with caution the introduction into Brazil, and it's clear that that Artemia has been introduced into a number of different areas. Has there been any example of documented impacts of these introductions, because potentially you're introducing something that could have quite a significant impact on the local ecology, either positive or negative, or has it not been looked at?
Yeah, well, happy to say a positive impact in those places where it was done the right way in terms of the species, in terms of the environment. And again, the best example is Brazil. By introducing Artemia, the salt quality has gone up. Why? Because the Artemia is a filter feeder and will in fact convert particulate organic matter, bioflux, algae into Artemia biomass. The negative item could be that, and I know that it has happened in a few places already, where the wrong species is introduced in natural lakes. This is something that by all means needs to be prevented. All the salt lakes, for example, in Central Asia, I have been in meetings where people are considering to introduce Great Salt Lake Artemia, Franciscana, etc. I always strongly try to convince them that this is a very bad idea to do, because on one hand it might wipe out the local population, but it might wipe out the local population, and at the same time the species that is introduced might not be adapted to the climatic conditions in terms of the hatching after the winter. It would take too long to explain me here these aspects of diapause.
Thank you, Graham, for your question, and Patrick. So now we are running out of time, unfortunately. So I will now close officially the seminar.
Amparo,
yes.
is it possible to send me, because I see that there are a number of very interesting questions in the chat box. If you can send me, I will reply by email to the people who addressed the question.
That sounds good. I will also keep the meeting room open for further discussion, but now the recording will be stopped. And also before closing, I would like to inform you that after the seminar, I will be sending a link to our seminar recordings repository, which is available on YouTube, but it is unlisted. So only people with these links can have access to the playlist. And you will see the playlist of 2018, 20, and 21, and soon we will have also 2019, which Felix is working very hard on it, because it takes quite a lot of time. Then I will send also, I saw some links that were sent by Valerio, Melba, and Matthias. I will also I will share also these links together with the links to the repository. And now I just have to thank everyone for this fruitful discussion, and thanks again to Patrick for the presentation. And I hope to see you in the next seminar. Thank you very much.
Great, thanks very much.